So to finish up 1.7, we have rational inequalities, which we're going to treat just like the higher order inequalities. Okay? So suppose I have this. I want to solve this. 5 over x plus 4 is greater than or equal to 1. Okay? Now, what is tempting to do, okay, tempting, is to go ahead and multiply both sides by x plus 4 and to get this. If you did that, you'd be wrong. The reason being is when I multiply both sides by x plus 4, depending on what x is, I could be multiplying by a positive value or possibly a negative value. Then I don't know if I need to flip my sign. So we need to avoid multiplying and or dividing both sides by a variable. So how could I fix this? Well, what I could do, so if I go the correct way, I could do 5 over x plus 4 minus, and notice I'm going to write it as 1 over 1 is greater than or equal to 0. So I just subtracted 1 from both sides. Well, now what I can do is I can go ahead and combine this into a single fraction. To do that, I need an LCD. My LCD is x plus 4. So what I'm going to do here is I'm going to say, okay, 5 over x plus 4 minus, this is just going to be x plus 4 over x plus 4. Notice how I multiplied by x plus 4 over x plus 4 here. Why did I do that? Well, the reason I did it is to get this as a single fraction. 5 minus x minus 4 over x plus 4 is greater than or equal to 0. So why do I care about that? Well, I guess first I should simplify. This is going to be 1 minus x over x plus 4 is greater than or equal to 0. And now that I have this, now just like when we multiplied two values and we looked at the zeros, when we're dividing the zeros and the point, the 0 of the top and the point at which the denominator is 0 is where the sign changes can occur. Okay? So I see that I have a 0 for x equal to 1 if you look at the top, and I have an undefined point at x equal to negative 4. Now what's important to remember is that the undefined point, it must be an open circle, right? Even though it's greater than or equal to, okay? Because we can never have division by 0. So that's what I'm going to do. I'm going to do the same thing I did for my higher order inequalities, as I'm going to make a line graph. And I'm going to put in the 0, okay? And since it's greater than or equal to, which I'll circle that, meaning I want positive stuff for things equal to 0, I'll fill in the circle. And at negative 4, I'm going to use an open circle because if x was equal to negative 4, I'd be dividing by 0. So we have to remember to include that. So that's a very important thing to remember with this. And then I'll go through. I know these are where the sign changes from positive to negative or negative to positive can occur. And I'll pick some test points. So if I choose negative 10, I will have 1 minus negative 10, which is a positive, divided by negative 10 plus 4, which is a negative. Altogether, that gives me a negative answer. I don't want negative stuff. Try the point in between here. 0 is probably pretty easy, right? 1 minus 0 is positive. 0 plus 4 is positive. Positive divided by positive is positive. I do want that stuff. So notice what I'm shading in here. Finally, pick a point out here, say 10. 1 minus 10 is negative. 10 plus 4 is positive. Negative divided by positive is negative. I don't want that. So what's my final answer in interval notation? It is negative 4 to 1, but including the 1. So there's my answer. Let's look at one more. B, negative 5 over 3x plus 2, greater than or equal to 5 over x. So once again, very tempting. If it was, if this was an equation, I'd do cross multiplication. It's not though, and I don't know if I need to flip the sign or not. So I'm going to resist that temptation and get everything on the same side. Minus 5 over x is greater than or equal to 0. And then I'm going to try to find an LCD so I can combine it into a single fraction. LCD is x times 3x plus 2. So here I need an x over an x. And here I need a 3x plus 2 over 3x plus 2. Now we'll get negative 5x minus 15x, I'm doing the distribution and I'm including that negative, minus 10 all over x times 3x plus 2 is greater than or equal to 0. Okay, so far, so good. What that's going to simplify to is negative 20x minus 10 over x times 3x plus 2. That's greater than or equal to 0. And usually it makes things easiest if we factor out what we can. So what I'll do is I'll go ahead and I'll factor out a negative 10. And then I'm going to get 2x plus 1, x times 3x plus 2, greater than or equal to 0. And now we're going to do the same thing we did before. There's a few extra things, but that's no big deal. What are my zeros? Well, they're the things that make the numerator equal to 0. So I get that from 2x plus 1 equal to 0. That means that 2x equals negative 1 or x equals negative 1/2. So there's a 0. I'll put it on my number line. So I have 0 here. Well, I guess I'll just start with negative 1/2. What are my undefined points? And we're remembering that these are going to be open circles. Well, the undefined points are going to be x equal to 0 from this part. And from here, if you set this equal to 0, you should get x equal to negative 2/3. Okay. So I'll put those on here. So since it is greater than or equal to, I'll shade in that negative 1/2, but the undefined points, of course, have to get open circles. So there's negative 2/3, here's 0. And we know that these are all the points at which the sign of the whole expression can change. So I'll pick some points. Let's start with negative 10. Now look, I have a negative, right? Negative 10. Let's see, if I put in a negative 10 here, this will be negative, this will be negative, and this will be negative. So a negative times a negative over a negative times a negative, altogether I know that that's a positive, and I want positive stuff. So I'm shading all this. Let's take a point in here, okay? A good point in here, now it's a little hard to see, is negative 0.6. I know that's in between these two. I know the first part's negative. The next part right here, 2 times negative 0.6 is negative 1.2. So I know that's going to be negative. Down here, I know this is going to be negative, negative 0.6. And I know right here, this will be negative 1.8 plus 2, which will be positive, and we will get something negative. If we move to this next point, let's pick a point like, say, negative 1/4. If we use negative 1/4, what you'll find is that we're getting a negative times a positive over a negative times a positive, which should give you something positive. So we want the positive stuff, we'll shade it. And over here you can pick something, we'll pick something like 100. We're getting the negative from the negative 10, a positive, positive, and another positive. Altogether, this is something negative. We don't want it. So our final answer, if we read right from our graph in interval notation, is going to be negative infinity to negative 2/3 union negative 1/2, including all the way to 0. And you should be good. That wraps up section 1.7.